let's get started. So today I want to improve the performance. So right now it's a bit laggy, and especially when it's loading new chunks, it's not the fastest in the world. Like it's not a champion. It's doing good enough, and despite the drawing artifacts, whenever we get into a different sector, then it starts loading like crazy. And that's because, well, first we are in debug mode, and I honestly want to improve the debug mode first. So whenever I hit the compile and release, it's always going to be better anyway. So it's not like release mode is going to turn worse. Oh, yep, I forgot to update. So that's going to be chunks generation and multi-threading. So the first bit I was to look into so I was about to create a thread and basically move all the chunk generation into the thread instead of being used. Let's see, where is it? Where is it being used? So it happens on tick right now. So, but it needs a frame context. And from the frame context, it's just getting a command buffer. So I guess we can create a command buffer just for the chunks generation. No, actually, no, we don't need the command buffer. Yeah, that is something that I wanted to take out of this function and just say generate chunks, even though I could just move the content, the whole content of the chunks generation out of and yeah, maybe move it into the thread itself, because there's not going to be much in the thread. So where is this being used? So this is being used in the vertex buffer update, and that's good to happen like in the main thread, and we actually want that to happen in the main thread. Let me go back a little bit, and first of all, let remove the dependency from the main command buffer and say that generate chunks will generate the chunks, but then the actual update will happen later, and the swooping will happen at another time, because what is consuming more, what is blocking here is the actual neighbors and meshing. So this is the bit that I want to take into a separate thread. Hey, latte. Oh, quiet. So let me increase the loudness a bit. Is it a little bit better now? Maybe I'm getting a bit too much. If I increase too much the gain, then it's gonna be on the overdrive side. Maybe I should just try to speak a bit louder. Okay. So I should probably try to return from this function a bunch of objects that need to lead to the update, and maybe I can generate the chunk itself that needs to then finish the operation. Well, it's going to be the chunk and the chunk data. So something like a chunk update structure, or maybe just a pair of a chunk and its chunk data to be updated. So we get the buffer, we get the buffer suballocation, and this is used for, yeah, maybe even the buffer suballocation. I don't know, why should this happen? Yeah, this can happen like in here. There's no race condition on the main thread anyway. So this is fine, and the actual update can be done somewhere else. And the chunk creation is not much anyway. So that's just a bunch of data being copied. And instead of being emplaced, or should it get emplaced? Because if it gets emplaced, then there is going to be a lock. And even though the amount of data is not a lot, cool. I'm glad you can hear better. Okay, let me start doing this. I'm gonna need a struct that I will call chunk update. And that needs to encapsulate like either the chunk update but also the chunk creation. So how would I do that? It's got a chunk index. Yeah, let's try to do the simplest version first. I'm gonna use a mutex and just allocate the chunk. So we're gonna need mutex stuff. Maybe a condition variable to wait, but I can do that later. So let's delay everything that I don't need right now. Oh wait, I didn't create the mutex. So that's gonna be a stud mutex. Buffer mutex chunks. No, actually chunks mutex. So the allocation itself. So there is the allocation, and then it's gonna check for the data if it exists. Yeah, the sub allocation maybe a bit of work. So yeah, that might be a bit too much work, but it's gonna improve anyway. So it's not like it's gonna get any worse. Hey, 42x, welcome back. Yeah, no worries. You're always welcome. I'm trying to improve the performance because right now when it generates a lot of voxels, it's getting bottlenecked on the main thread. So we got the chunks mutex, and I'm gonna lock it. And this is gonna spin lock, so it's gonna wait till the lock is available. And I guess I can release it here. And, unless it breaks, yeah, maybe it's better if I use a lock guard. A lock guard for the chunks mutex. And that's it, yeah. And the same pretty much applies to here as well. This also makes sure that whenever you're doing the free, well, do we know if the free is gonna? So we do the free, but we don't really know if it's still in use. So this might be, it's not an error because the buffer still exists, but we might be drawing some data that is dirty, and that's in change. Well, no, not really, because we are only doing the update at the next command. So it should already have done the previous one. So I just started really. I'm trying to move the generation into its own thread. That should free the main thread to keep rendering, and so that should give a much smoother experience. Okay, so what I need is the chunk mesh. It's gonna be a chunk mesh for the shader vertex type, and that's the data. I'm gonna need a reference to the chunk. That's not very safe. So how am I gonna get a reference to this? Maybe, yeah, the index. It's an array, so that's going to be chunk index. And that's pretty much it. I wonder if I suballocate now, or I can suballocate later. Yeah, I guess I can do this whole operation later. I just need to make sure it's here and delay the whole operation. So we had to create a new chunk which is not generated yet. However, here the chunk will already exist. But I guess I can just check whether the buffer has something in it. So in this case, the buffer will be empty. Yeah, I think I can just reuse this function. So the chunk is allocated. It hasn't been created yet. And then I can just have a vector or a queue. Yeah, not a queue. I'm gonna execute all of them all at once. So that's going to be a vector of chunk update and make it not non-copyable. And yeah, chunk updates. So chunk updates is gonna get a chunk data. And the index is going to be the size of chunks in this case. And this is the size, it's size -1. Yeah, that's the index. And yeah, chunks is not even needed. Well, yeah, actually, it needs to retain this data too. So the set index, okay. So there's a bit more to it. And let me just dump this into here so I don't get it lost in the clipboard. And what's the type? This chunk, it's got indices and stuff. This is also non-copyable. Yeah, we don't want it to be copied around. It's move only. So I'm gonna use chunks update. Yeah, I want the structures. The designated initializers. And I'm gonna put the set index as well. So that's going to be the set index. GLM for the color. And the sector, yeah. So the sector is an I3, I think. It's an I-vect3. So we have the color, and finally an I-vec3 for the sector. So the data is the chunk data. Then we have the index. We're gonna need to move it. Chunk data. Yeah, that's gonna have to be moved. Wait, what? Attempt to use deleted. What's wrong with you? No copy. Do I need to make it public? Hmm. Well, yeah, I'll be back on it in a bit. So the chunk index will be chunks -1. Ah. And again, what is next? Scholar. Do we have the color? I'll just move this bit right into here. Then we have the set index, and this can also, set index is the one before. Set index, it's yeah, it's just the same as the chunk index. Okay, what's wrong with this? So I'm trying to use a deleted constructor. What is trying to use? The constref, the move constructor. And why is it missing? Oh well, yeah, I should probably, yeah, this can be private, and there should be a generate helper somewhere. Come on, show me what you got. Generate code. And copy and move. So what is this? No, I don't need any of those things. So I want the copy operation to be, yeah, that should be deleted already. Skip that and give me the, yeah, what? The move operation as a default. Okay, what's wrong? What's wrong now? Oh, still this one. Chunk mesh. Oh, okay, wait. Is this the one that I was looking? Yeah, chunk mesh. What's wrong with you? Ah, this is a copy. Attempted to to use the deleted constructor. Oh, weird. Guess I'm missing something. Well, I mean, it should be non-copy. So why would you want it to be copied? You should just move it. This is because this is const. Damn it. Okay, no need for this. Cool. C++ traps. And this is gonna compile. Let me see how can I make this work on the one underneath. So the chunk index is going to be, so this is populate the chunk index. The set index is the chunk index. Yeah, that's pretty much the same thing. And you got the color. You don't need to allocate it, so I think it's fine to just place this in there. After we have the chunk index, the color is randomly generated at the other one. The lock, oh, I forgot the lock. Well, I don't really need the lock anyway. For this to work, yeah, I don't need the lock in this case. So reusing it is not gonna change the vector. So maybe, I don't know, that's a hypothetical. And chunk index is gonna be this guy here, and the same goes for the set index. Whoa, that's way shorter than I was expecting. Cool. Fewer, less code is always better. Unless you are messing things up. Amazing! Now, instead of generate chunks, I want an update chunks that uses the frame. Cool. So, new function here, generate chunks, generate neighbors, and then update right after that one. It's going to be a void update chunks. That's going to get a const vk frame frame context vk utils. It was just the next line, and frame okay. Let's move the content down below. So for each chunk, auto should be const auto reference to update chunk updates. So if chunk dot data if the chunk's got some actual data, then we do the update. So it's going to be size, shader, blah, 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 and chunk data. We do have the from. From is just frame. Oh boy, we're getting close. Chunk is just a frame. Chunk is just a frame. What did I just say? So chunk. Wait. The actual chunk is not this. But it's chunks by the index of the chunk dot chunk index. Create using the chunk dot color. Then it's going to be chunk dot sector, chunk color, chunk dot set index +3. Wait, set index +3. Okay, it's gonna be index here, and +3 is fine to be here. Then again, the actual data. I need a new line, and that's it. Wow. Can it just be it? Wait, why do I have another create here? Oh, okay. So that's because it breaks. It should not break in this case. And instead we're gonna have an else case. So this is the else path. And it's gonna do pretty much the same thing, except for some of the data it's gonna use. So the sector is fine, the color is also fine, the set index is fine, and it won't have any data. Okay, yeah, that's it. Even though at this point I'm not sure it makes sense to have chunks with no data, so that's something that we can clean up. So do we do anything different here? With the oh yeah, the free bit. I'm not doing the free. So if we have data, well, this says that we're gonna free create. Is create gonna free something? So what if we create, not because it doesn't know about the, so it cannot sub-allocate the main buffer. Yeah, it doesn't know anything about the main buffer. So we're gonna need to deallocate here before any data is used. And that is the sub-free. Here we have sub-alloc, and in case yeah, otherwise it's going to override the sub-allocation anyway. And so this is going to happen in both cases. If the chunk has a buffer, wait, what did you just? So I want to keep that. I don't know, this IDE's clipboard handling is getting weirder by the day. Buffer dot allocation So if it has an allocation, then let's free it up. And that's it. Sub free. Well, maybe sub free can check whether it's valid. Yeah. What would happen if I free something that's null? If allocation is not, oh, okay. Yeah, it actually checks whether it's null or not. So technically, this should not be an error. Okay. Looking good. We only have missing the chunk generation step. That's gonna turn into an update. And yeah, XR mode and also the windowed mode. This turns into update chunks. Not generate update, but chunk update. I'm gonna test if this thing even builds. Oh, it doesn't build. I was sure it was going to build. So what's wrong with this? Must appear in a member declaration. Wait, what? Set index must appear in member declaration order. Oh, okay. Can this just fix the order? Ah, it's not able to pick up the order. So what did I get wrong? So it's chunk index, set index, color, and sector. Chunk index. Wait, where is the data? Data. Chunk index, set index, color, and sector. Data chunk index, set index, color, and I forgot sector. What was sector? Sector. And that should complete all the data that's needed. Oh, why? What's wrong with this? It's the size requires narrowing convention. Okay, just do it. Chunk index. Which one is wrong? 221. Okay, this one is wrong, of course. Is it that bad? Set index. I could make it full 64-bit size, but not planning on having so many anyway. It's not like it's gonna be billions of allocations. Why didn't it complain about this? Ah, because this is the back. Okay, yeah. It's not size. Well, well, well. The moment of truth. But in reality, nothing is gonna happen because there is no generation. So everything will be empty, and this is a successful failure. I just successfully failed. And that's alright. So who's gonna generate the things? I would say I can just call generate before. Yeah, so generate chunks is gonna happen right before. And the result should be kind of the same as before, if something works. Let's check. Oh, come on. Mosquitoes. Which is not the case, apparently. We got stuck. Not cool. Not cool. Where did we get stuck? Maybe it's maybe it's generating too much data. Probably get stuck here. So we need to generate 3000 chunks. Mutex is fine. You generate a chunk and then okay, we make an okay, I got it. I got this. So it's never ending because the update chunks then don't free the chunks to be updated. So that's gonna need to be cleared. Come on, go away. Come back here. Mosquitoes. It's time. It's their time for breakfast. But I don't want to run it right away. Instead, I'll go back to debug and see if at least the function ends. So does this ever finish? No, this doesn't end. Okay, that's the problem then. Why is it getting stuck? You get all the neighbors. It's trying to generate all the neighbors. Okay, that's why. Need to break it here. Come on. I can't. But I'm gonna get you. Come back down. How are they able to disappear that fast? Oh, here it comes again. Come on. And it's gone. Okay. Yeah. It's gone. Ah. I hate allergies. Damn it. That's one break. And this is another break. This means that it's gonna run one generation at a time. Even if it's empty. But hopefully this is going to be... Oh, come on. That was just a fly. So we should begin to see something at some point. Maybe the space is too big. Oh, okay. Something's happening. Nice. The actual generations are happening. Okay. Oh, wow. Now it's super fast. Wow, I can feel the difference. But the generation is a bit slow. That's because it's doing nothing most of the time. And when the data is generated, there should be some data. I wonder if it makes sense to have does it make sense to have such data for does it make sense to have a chunk allocated when it's empty? Let's see. See if it makes sense. So when the chunk data is empty, we're just moving forward. If chunk data dot vertices is empty, just continue the generation. And the same happens here. Hey, okay, got stuck. Okay, I see. Maybe we can generate this thing and have it like auto blocks. So let's split the generation chunk data into mesh data blocks, and if blocks dot wait, what is blocks? Chunk data yeah, blocks dot blocks. Size, what is size? Blocks is empty. Okay, that's could be more convincing. If this is empty, and maybe you can also check this as well. Like if this is empty, then they are. This can't be const. I'm gonna be right back. Catch you in a few minutes. Okie dokie, I'm back. Just got some sugar. I needed to eat something. And I have cocoa beans. Lovely cocoa beans. They're a bit bitter. But I like the taste. Maybe you can even hear the crunch. So let's get back to this. Blocks, okay. Blocks data. Yeah, so that's it. And we do the lock only there. Same happens here. Okay, this should be all I need to do. We still haven't got into the multi-threading and it's already working much better. Because it's not clogging the presentation. So now it's generating. Why is it generating so much? It's taking a lot. Maybe I can optimize some of the functions. Okay, generated new chunk. And now it's stuck generating more chunks. Ooh. Okay. That is a bit heavy. But it seems like it's working. So I guess I can really move the stuff. Yeah, I'm back. I can probably move the generation here. And that's gonna be in a while loop. Just trying to generate. It's gonna use a core just for that. And remove it from here. Let's see if it now going to work. Oh wait, nobody started the thread. So it's not going to work right away because I forgot a little bit. So the thing that I forgot is starting the thread, and that needs a reference to the thread. So that could be instead I'm just gonna call it chunks thread. So that is, I feel like I need some music. Getting too much noise. So chunk thread is gonna be a new thread that will start. Okay. We'll start at up base generate thread, and it's gonna get this, and that's it. It will need this parameter because it's a member thread, and okay, this is gonna run forever, so we're gonna need a way to stop it at some point. But for now, that should be enough. Compiling. And okay, no chunks has been generated yet. Okay, got one chunk, so at least we can keep moving. But the chunks generation is so slow. Here's a second one. Why is it so slow? Weird. There's a new chunk. Okay, there's something wrong there. Did I introduce a copy? Or maybe I introduced a copy. Generate chunks. So this is creating a block of data, which is a chunk. And this should be no copy. Flat. And block. Okay. So if the block is empty, then just keep going. And the chunk data is going to be the meshed. And this takes a reference. So, okay, there's no copy happening here. Got the chunk data, and the chunk data is moved. Yeah, that should be all right. Cool, cool, cool. Okay, I want to debug this because it doesn't make much of a sense. Maybe I can just so loggy empty block. Okay. And the same here. This is empty block. And it's gonna be an empty chunk. Let's call it. And the same there. Okay, let's see what happens in the log then. Okay, empty chunk, empty chunk. Wait, why empty chunk? Why is it getting empty chunk? And it's not detecting that the blocks are empty. What happens? Why? Like why? Oh, air? Maybe because it's filled with air. Okay, that would make sense. Air. Oh, okay, yeah. Blocks. Hmm. Blocks are always full. Well, that's a lot of waste. Okay, that is a lot of waste, but yeah, that is only per chunk, per chunk. Yeah, it's gonna be a chunk. So that's only for chunk. Okay. Okay. So chunk empty, chunk. That's gonna be always empty. Well, that might be okay, I guess. It's gonna check whether there is. Maybe okay. I'm getting to it. So when the chunk is generated, then this is already going to check whether there is something different than air. So in the chunk data, we can have an empty. Boo, empty. So there's gonna be not like that. Empty, which is false by default. Is it empty? Well, maybe it's true. So this is empty by default, and when the block type, the chunk data, where is the chunk data being generated? So we got a temporary, and the blocks. This is where the blocks are generated, and chunk data. So this is generating. Okay, this is generating also the neighbor. So this empty. Yeah, I could have. Oh, how many O's? So empty. Empty is gonna be true unless there is anything that's the center. And the block type is gonna be air or so empty. It's empty. It's gonna be ORed. It's no wait. It's gonna be empty is true. Empty is false. Not empty, but full. Yeah, full is false, and full is gonna be ORed with type when the type is not air. And then it's just not full. So if it's not full, it's empty. Chunk data. Don't really need the constructor. Okay. And this is gonna be not for what's the problem with this? Raise initialized is not the problem. Wait, what? Okay, maybe I'll say size sector blocks and empty. So dot size equal dot then dot sector equals to then dot blocks equals to and dot empty equals to not full. This should be fine. Now let's use this data in here, and instead of checking whether the blocks are empty, I'm gonna check if it is empty. If the blocks data is empty, and this is gonna make it also here empty. This could save some computation already for the empty bits. So the empty ones should be ignored. Empty block. Okay, we're getting empty blocks. Empty blocks. Why is it so slow though? Empty blocks. There's so many empty blocks. But it's not super fast. How slow can this be? Am I doing too many allocations? So this is very slow. And maybe I should check at the allocations happening. So in the generation function, let's see, generate chunks. There is the first this loop here, and it's gonna look for indices that are available. Now, how many indices would I even need? Like indices, chunk indices, and then it goes through the neighbors. So for each chunk, it's gonna look for. Yeah, this is not very optimal, and there will likely be a lot of bound checking. So the generated neighbor. So generate neighbors is already. Generate neighbors has. Yeah, maybe I should measure how much time is spending into doing things. There should be some sort of profiling in this, but for sure. So neighbors is emplacing. It is emplacing, but it's also allocating a lot. And there is a side. It's going to be from -2. Okay, I think we can pre-compute this because it's always going to be of the same size. So neighbors really can be reserved, and the side from minus side to side. Okay, I think I can. This is gonna be like. Yeah, this is mostly like this. Neighbor span is the size. And that's exactly what I'm passing here. Neighbors span. Okay, and that's the same value. Okay, so this is going to be size. And this is gonna save a lot of allocations already, and it can't be not const expr. Reserve, and then in place. Okay. Then how many other allocations do we have? So this is neighbors, vector, and hopefully this should be moved rather than being copied. There's a chunk count, generate neighbors, okay. Flat generator, the constructor is not, it's not doing anything. And chunk indices, deq. Do I really need a deq? If chunks, yeah, it is using it here for enqueuing and dequeuing. So the indices, yeah, this, I feel like this should not be generated every time, but only when the sector is changed. So chunk indices really should not be in here. DQ, generate, and it's probably also time to move everything into its own class. But let's see if I'm already getting a little bit of a speed up. Yeah, I can feel like it's going a bit faster now. And yeah, kind of. But wait. So the last, I'm gonna make a static glm ivac3 like sector, which is current sector. So the current sector will be something. So this is something like, I don't know, one. I just gonna put some because it's different from 0. It's different from the beginning one. And if distance, play camera position. No, actually camera position. If the new sector is different, unless it's the first generation, so the first generation is gonna have. Okay, yeah, I got it. So the first generation is gonna have the chunks that are empty. So if chunks are empty, then always do the generation. If the chunk is empty, or let's say auto new sector, so if the chunk is empty, or or is not the same as a new sector, So if the sector, camera sector is different from, why did I do not like this? It's an IVAC 3, and what is sector? Yeah, it's an IVAC 3, and the floor, and this needs to be an IVAC 3. Okay, now it's good. So if it's different, then let's use, this is a static. It's gonna be static, and chunk indices. Wait, why did I get that? Neighbors, also neighbors. So these are all going to be moved upwards. Indices, neighbors, and this isn't static, but this is static. So I got the neighbors, which neighbors. Well, the neighbor. What are the neighbors even used? So the neighbors are only needed in here or in there. Yeah, so the neighbors are needed. And then the chunk indices are the ones that need to be generated yet. That only changes. That only changes when the sector changes. So sector player. Wait, I got something. Okay, I just moved it already. Neighbors. Neighbors is to be generated, but not here. So generate neighbors. This is just a vector. So this is going to be a vector of GLM vac 3, IVAC 3. And neighbors will be set here. It's gonna be set there. This is not necessary. And also this bit here need to be moved after the neighbors have been set. We generate all the indices, chunk indices, but needs to be cleared first. Chunk indices dot empty. No, wait. Is this? No, this is just a check. And clear. Yeah. I always get confused because Unreal uses empty to actually empty the data. Oh boy. Cool. This should speed up things if it works. If it's gonna work, then it's gonna speed things up quite a bit. Okay, it started, but nothing is happening. Cool. And why is nothing happening? So the chunks, yeah, it should have something. Weird. Okay, let's break into the function to see what is happening. So we know everything. Then wait, we haven't not moved. Okay, but we also don't have anything generated. So it's not like okay, the distance as there is a new distance. Okay, we have not moved, but also the chunks is empty. Ah, so this was not intended to be used like this. So if the chunks is empty, then we're gonna compute a new sector. And if the play, yeah, let's try to force for the generation. If the chunks is empty, so at least the first time it should generate something. Otherwise, you'll never get out of it. Okay, and that's a sector. It is empty. We compute all the things. Clear that out. Hey, what? For each chunk, we don't have any chunk. And okay. Wait, these are the chunk indices. Okay, we don't have chunk indices yet. All right, I guess I can't use this way. Yeah. So the chunk is cleared, and we don't have any chunk, but we will have chunks. So this is only telling which chunks are already available. So this is gonna check for chunks that are not in the are outside of the neighborhood. And the neighborhood, when the neighborhood is generated, then chunk indices is gonna check whether there are no chunks, so it cannot check anything, but the chunks will be generated. Well, maybe this guy here cannot be moved after all. So let's say we cannot move this, and it will emplace something, chunk indices. So if it's not empty, then that should be the list of the chunks. Yeah. Okay, there's lots of empty blocks. And empty blocks should really be faster than this. Why are empty blocks so slow? Is it the allocation? Oh yeah, I think it cut out. Well. Um, did it finish? So I want to run this and debug mode. And for some reason, whenever I enable debug mode, everything, yeah, I don't know, it complains about GLM. What is What's wrong with it? But yeah, let's see what happens when I try to run it and build everything. It's gonna take some time. But the problem is that then it's gonna leave the state in a way that it always complains about the modules. So that might be the main issue. So having different targets is the problem. Well, it could be. So okay. And well, that's weird. Why is it so slow? It can't be. Oh, wait. Is it slow because of the logs? Yeah, it could be. If this is the case, really, I don't know what to say. That would be so embarrassing. And that's kind of that is one of the causes. But then it's still super slow. Incredibly slow. This is like too slow. What is can't be this slow. Like it became even slower than than it was before. This is so weird. What is happening? Is it lock? It can't be the lock. The renderings are never locking the lock anyway, so it can't be the lock. Chunk update. Wait. Update chunks. It's gonna clear that out. And this would actually need the lock. And it's going through the chunk updates. I don't really know. Yeah, this probably also need the lock because it's doing an update. Whoa, that's so fast. What the? What just happened? What just happened? What just happened? That's like day and night. That's a blazing fast. Just because I added a lock? Can that even be the case? Man, that would be so weird. Like locks? I know locks tend to make things a bit slower, but putting a lock and having everything, no, that wasn't the case. What did I just change? I don't remember what I just changed. No, I need to get back. I need to get back to what I just did. I removed the brakes. Okay, that's why. So it breaks whenever there's is that it? Well, okay. I guess let's just lock a guard, and then I'm gonna add the lock guard here back. Chunks, chunk update, and chunk. Well, the chunks is only handled by that. Okay. Well, that should be good. And I'm gonna remove the brakes here too. Okay. It just unlocked the full power. Oh, see you, buddy. See you next time. But yeah, I would say we succeeded. Just in time for you to go. I don't know if you are still here, but you can appreciate the fast generation now. Very smooth. Okay. See you next stream. Let's see what's happening under the hood. Why are there so many streams? Okay, looking good. So I guess the next step is just to get everything into instanced rendering, but it's probably time to see what happens on the quest. There are probably too many chunks right now, and each one of them is 32 cube, which is a bit too much for the quest. But let's see. Ah, and the camera just disappears. I am locked. Okay. Oh, wait, I'm back. No, this is the wrong camera. Let's try to put it back. Is this gonna work? That should be. Hey, something is wrong. And still not connected. Okay, no. This is still using the wrong one. Okay. Alright. Alright, I'm back. And I downgraded my camera. Let's go on the quest. This is going to be, oh yeah, it's a release build. So that's already ready to go. Wait, what? I need to have some background music. Okay, let's get some music going on here. No dubstep, please. This sounds like a good combination. It's gonna be super loud. Okay, it's a bit loud. Okay, that's good. Okay, it's compiling. Just compiling. Building. Oh wait, something's wrong. What's going on? It must be declared before it's used. Oh. Okay. Did I not do that? Wait, where is it used? Give me the arrow back. So that's used here. But only cause C and F? Not cause F. So that's oh yeah. I didn't add the headers, and here we need thread. Yeah, MSVC is much more permissive for if you forget headers. Okay, getting there. Oh, installation successful. Let's see if it runs. And I want to see here the logging. It's generating chunks. Oh wow, super cool. Oh, wow, it's even running like at speed. That's amazing. Whoa, that's amazing. It's running like well, no, kind of. Well, that is surprising. It's a nice one. Yeah, I need to adjust the scale instead of being like in a small world, super high, super dense small world. But I don't think it's gonna handle more. Okay, so the scale is a bit off and everything is so small, so the scale is gonna be one of my next tasks. I want to make sure, but the performance is quite good, but I was in release already. So the performance is not bad. The only thing is that I need to switch I need to switch to garbage collect or resize. Okay, this is a milestone, so I'm gonna commit this stuff. So this is multi-threaded generation. multi-threading, multi-threaded chunks generation, multi-threaded chunks generation. Okay, cool. I guess the next step is to add some texturing. Feel like it's getting a bit boring. And oh yeah, before that, I really need to fix. I really need to fix the water rendering. Okay, so smooth, nice. Cool. I think I'm gonna take a break now, and I'll be back on the second part of the stream for fixing the rendering. I think so. First will be fixing the rendering, and then adding textures afterwards. So for now, just see you later.